Anytime where you have a situation where your subgrade or base course is really soft, it's hard to work with.
To produce a better, stronger pavement structure.
Saved about $6,000 over the life of the project.
There's limited natural resources available.
It's a good recycling project. Reuse what you have.
25 to 30% of the cost of a complete mass excavation.
You can do it in a short amount of time.
It's like paving on top of existing asphalt. That's that hard.
It allows us to go into areas where the subgrade has gotten soft because it's wet.
The fly ash bound together the existing pavement and almost had like a concrete base underneath it.
So that in turn goes right back to the customer as a cost savings.
This adds to the suite of options that one may have.
Come and look at the things we've done. We recommend this.
Until recently, base stabilization for a road like this was typically performed by removing and replacing soft soils and other previously used materials. However, a new construction technique is now being used, in part because coal-burning power plants now use lower sulfur coal in order to meet the stricter sulfur emission standards of the Clean Air Act. Not only has air quality improved with the cleaner burning coal, an unexpected benefit was realized. A new type of fly ash, designated Class C by ASTM, is now being produced, and it possesses some rather unique and valuable properties. Fly ash, a material that was once destined for a landfill, is now being utilized in dozens of applications, ranging from cement production, concrete, and concrete products to aggregates, and for reconstructing asphalt roads like this one in Waukesha County, Wisconsin. For the next few minutes, we're going to look at one way in which this valuable tool, cementitious Class C fly ash, is making a big difference in how we think about road reconstruction projects like this one. A unique process of cold-in-place recycling of asphalt using cementitious fly ash is helping to save time, money, and the environment. In a typical cold-in-place application, the existing hot mix asphalt layers are pulverized, graded, compacted, and used as a base layer for a new hot mix surface. In recent years, stabilizers have been added to the pulverized material in order to improve the structural capacity of the layers. One such additive is Class C fly ash. Because of a high concentration of calcium oxide, it is self-cementing. Therefore, as a stabilizer, it can be a much faster and more economical method of dealing with soft compressible soils, wet soils, or clays that have a tendency to shrink or swell, as well as use as a binder in cold-in-place recycled asphaltic concrete. The process goes like this.
I can give you an example. When we did this year, it was down at the Pleasant Prairie Power Plant, and what we did is there's an existing roadway that has a lot of traffic, and it was need to be repaired. What we brought in is a pulverizer to grind up the existing asphalt and grind that up with the base course. We went down about 12 inches. We pulverized that all together. We compacted that down, watered it, and then we brought in that cold-in-place fly ash, laid that out, we watered it, and then pulverized that in with the base course and the asphalt. We compacted it after we did that, and what that allows us to do is firm up that base course.
As a test, this 1.5-mile road in Mequon, Wisconsin was paved using 3 different types of cold-in-place recycling with a hot mix asphalt overlay. One section was paved using traditional cold-in-place recycling. Another section used an emulsion-based stabilizer in the pulverized material. And another 800-foot section was paved using Class C fly ash stabilization. The surfaces are tested periodically using a falling weight deflectometer, a device that measures the amount of deflection and resulting stiffness of the various layers of the road.
In a nutshell, what we do is drop the falling weight on the pavement, and the weight deflects the pavement. And from the deflection basin that's created by the falling weight, there are sensors in the system, in the machinery, that can determine the life of the pavement. What it does is it calculates the deflection of the different layers of the materials that are on the pavement, the base, the subbase, and the surface layer, the asphalt layer of the pavement. And we calculate the structural number and the life expectancy of the pavement.
The results at the Highland Road site have been very telling.
It was designed to be reconstructed using the cold-in-place pulverization process, followed by a 4-inch hot mix overlay. That was placed in September of '97. We monitored it before, after construction, and been monitoring since, looking at the structural capacity of the in-place pavements and the performance of those pavements based on surface distress measurements. And to date, we've seen that from deflection testing of the materials, that the fly ash section is producing a somewhat higher structural number, which infers an increased structural capacity for the pavement, which should relate to a longer service life as compared to the unstabilized base layer as well as the emulsion stabilized base layer.
The actual data from the post-construction testing using the falling weight deflectometer shows that the fly ash section of the pavement gave an 8.6% increase in structural number when compared to the control section, and a 4.6% increase when compared to the asphalt stabilized section. All this, of course, translates into cost savings. Roads are lasting longer, taking less time to resurface, and new virgin materials don't have to be trucked in. And in many cases, the construction season can be extended because areas that were once thought to be too wet in the fall or spring can be effectively stabilized.
When you want to compare between undercutting the subgrade, bringing in new material, or bringing in other stone, and you compare that to fly ash stabilization, there's a significant cost difference, especially when you get into bigger areas. When you have to excavate, bring material back in, that doesn't always work. Sometimes you can do that and you still have soft areas appear, areas that you can't put material over. Whereas with fly ash stabilization, once you get in there, you put it down, it gets very hard. In that situation down at Pleasant Prairie where we stabilized that roadway, our paving foreman was a little frustrated because the fact when he went to put his string line down to run the edge of pavement, he couldn't put the nails through that material. We were bending the nails over. So, I mean, it gets to the point where it can get that hard. You're not always guaranteed by removing the material, bringing new material in, that that's going to work. Usually it does. But with fly ash stabilization, you can almost be guaranteed that your finished product is going to last.
We were impressed with how quickly it worked. There are some modifications that we wanted to make and wanted to use here, and the companies that we worked with were able to make those modifications. One of our biggest concerns was dust and during the application, and by using the vein feeder truck we were able to cut down on the dust on this project.
If we can save the county or save any governmental tax base money, it's another option for the county engineers, county commissioners to use in their budgets. If we can stretch their road budgets and on top of that give them a better product, then it's a win-win situation for everyone.
Cold in place using fly ash stabilization can save tremendous amounts of time and money. However, the environment may be its greatest area of savings. Each year in Wisconsin, approximately 2 million tons of industrial byproducts like fly ash are created. The more of these we can utilize, the less that ends up in the landfills.
The department encouraged the use of industrial byproduct. We also would like to encourage the communities to look into the use of this material in their construction activities in their villages or cities, and understand the benefits of these activities, and which is also very environmentally safe and can preserve natural resources.
Wisconsin Energy believes that what's good for the environment is good for business, and we think this is an exciting example of why that's true. In fact, we're very proud of the record that we have in fully utilizing the byproducts from our plants. We're leaders in the country in terms of percentage of the coal combustion products that we beneficially use, up into the 90% range.
As a society, We have to look at green construction techniques and making use of the materials that we already have available to us, that we've already tapped in the past, rather than throw these things away and go after new natural materials. When we talk about sustainable development, what we're really talking about is making use of the materials that we have available to us now, that we've already tapped, and preserving the natural resources and untapped materials for future generations that come after us. Fly ash and bottom ash is no longer a waste product. It's a valuable mineral resource that's being used in a wide variety of applications and is a tool to engineers, contractors, and local government.
As you can see, cold-in-place recycling of asphalt using Class C fly ash has proven to be an environmentally friendly, cost-effective alternative for asphalt road construction. If you'd like more information, please contact Wisconsin Energy.